Red Hat. And I'm also an OVN contributor for 1 year as well. Today, we're going to talk a bit about OVN testing and CI. This is going to be an update about the state of CI and testing for OVN in the OVN open source community. Brief overview of what we're going to discuss today. First, we're going to have a look at current OVN contributions. And then we're going to check out all different types of tests that happen in the OVN world. So we're going to talk about in-tree unit and system tests. Also, we're going to have a look at end-to-end tests that are run with OVN-Kubernetes. We're going to discuss about control plane scale testing with ovn-heater, but also with a real CMS. And we're also going to have a look at what data plane performance testing happens for regression detection. And afterwards we'll put all this together and try to figure out what kind of CI runs, where, and when that happens. And finally, I'll try to discuss about how we can potentially improve all this. So let's look at current OVN contributions first. OVN is still a very active project. So if we look at the last 12 months, last year, we can see that there were at least 30 features or user visible changes that were contributed. And focusing on patches, for example, in general, there were 568 patches that were contributed in the last 12 months. That's quite a bit. So more than a patch a day. Now, for each of those patches or for each of those patch series, the developers, reviewers, and maintainers must do a bunch of things. So what needs to happen is that we need to ensure that the code is doing what it's supposed to do. And we do that by review, by manual testing, etc. We also need to ensure that the code quality is acceptable, and that happens at review time. What we also do is make sure that new code doesn't break existing functionality. And that's the role of CI. We also need to ensure that new code doesn't introduce control plane scalability regressions or data plane performance regressions. Both of these are also the responsibility of CI. And to add on top of that, this has to happen for every revision of the patch series. And most of the times, most patch series have more than one revision. So that's quite a lot of things that need to happen when contributions are received for OVN. Okay, let's start by looking at the unit tests that are defined in the OVN source tree. To run these, you need to build OVN and then issue the make check command. It's displayed here. In total, today we have 834 tests, and these are split in two types of tests. There are actual unit tests, most likely the ones that use OVS test in their definition. And some examples are ovn-features.at, ovn-ipam.at, lflow cache, and vplug. And what these do is actually call into code in OVN library code and make sure that that code behaves well for the inputs it received. So we pass it some inputs, we get the outputs, and we expect the outputs to be what is correct. Well, unfortunately, most of the tests are not like this. We also have the vast majority of tests that are system tests in disguise. So, for example, look at OVN-AT. These are often complex test scenarios that involve multiple simulated hypervisors and complex logical topologies. Sometimes we even run multi-AZ tests, multi-availability zones. So there's also OVN-IC involved. They run in OVN sandboxes. they use the obvious dummy data path, and alongside with that, they use the user space contract implementation. There's no real workload running in these tests. The workloads are simulated with dummy interfaces. And we run these tests multiple times. We have a matrix, basically, and we run the tests for conditional monitoring enabled or disabled, or parallelization on and off. Second type of tests we have in OVN are what we call system tests. In total, today we have 167 of those, and what they do is bring up a real single node OVS and OVN environment. And these tests run for each flavor of the data path. So they run for the kernel data path, for the netdev data path, so user space data path with netdev, and for the user space data path with DPDK interfaces. Workloads, or simulated workloads, are actually VEETs running in network namespaces. Some of these tests run multiple times. For example, for conditional monitoring enabled or conditional monitoring disabled. To run them, we need to issue the make check kernel command. Next, we have the in-tree multi-node system test. Well, today we actually only have one of those. What they do is bring up an OVN cluster in containers, configure a logical network topology, and run traffic across different components of the network. The tests use OVN-Fake Multinode for that. OVN-Fake Multinode is a project originally created by Numan, and it deploys plain OVN clusters with fake chassis running in containers. It's inspired from from Kubernetes in Docker. Each controller or computer node runs in its own container, and each container looks like a real OVN chassis. So it runs OVS, it runs OVN controller, and if it's a central component, it runs North-T and the databases. The nice part about this is that it allows us to run upgrade-like tests. So we can test with OVN controllers running newer OVN versions while being connected to North-T and databases that are running older OVN versions. To trigger the tests, you can use the make check multinode command. Next type of test is the end-to-end test with OVN-Kubernetes. OVN-Kubernetes is the CNI plugin developed and supported by the OVN.org community. Why do we run these tests? Well, essentially because we want to be nice. We want to ensure that we don't break OVN-Kubernetes whenever OVN changes. So what we do is run a subset of OVN-Kubernetes on end-to-end tests on any OVN revision. To do that, we build a custom OVN-Kube container image. And that container image contains OVS and OVN compiles and patched from scratch, so not from a distro or whatever. Then we bring up a Kubernetes cluster with Kubernetes in Docker, which uses OVN-Kubernetes as CNI. At that point, we run a subset of the upstream Kubernetes conformance tests and a subset of the upstream OVN-Kubernetes control plane tests. And hopefully this gives us enough coverage to be confident that we don't break OVN-Kubernetes with new OVN changes. Now, until now, we spoke about functional tests mostly. Next, we're going to talk about control plane scale testing. One way we do that is with OVN-heater. What are the challenges when testing the scale of the control plane? If we test with a real CMS, with OpenStack or Kubernetes, it's complex. You need lots of CMS-specific knowledge. And if a bottleneck is identified, it's usually identified in terms of CMS-specific components. So when you scale up the number of services, with so many service endpoints, things don't work well. But the problem is, how do you translate what a service is to OVN world? So it's not always easy to find the right community or people to fix the bottleneck once a bottleneck is found. It also makes it harder to implement a CI/CD pipeline, and that is because tests can only be run whenever the core OVN changes are consumed by the CMS. That's often months after they were actually accepted upstream in the OVN repo. But yeah, here enters ovn-heater. What's ovn-heater? It's a community project we started to simulate a CMS and to allow us to scale test the control plane. Essentially, it's a mega script to install, configure, run a simulated OVN cluster that underneath uses OVN-fake multinode. So it's a collection of Python and Ansible automation that provisions OVN-fake multinode nodes. It contains its own collection of libraries to define workloads. We use Python OVS to connect to the OVN databases. It also has integrated data collections for logs, perf traces, and so on. And we also do some amount of data mining. We generate charts, latency, etc. It makes it easier for core OVN contributors to actually test new features at scale, because we don't need the knowledge of the CMS in order to configure OVN. We can just use ovn-heater for that. That makes it straightforward to use for CI/CD. So what do we actually test with it? We selected rather specific real-world workload simulations. Together with the CMS contributors, we sat down and define scenarios that are interesting to simulate at scale. So OVN-Kube-like topologies, where we care about number of nodes, density of pods per node, and so on, and how all those translate to OVN. OpenStack-like topologies, where we try to map what computes and controllers are, same for projects, networks, VMs, etc. And then we came up with a templated test scenario, or a bunch of templated test scenarios that implement the above. And we start running those at different scales. However, testing control plane scalability on public infrastructure is not that easy. So if we want to run it in GitHub Actions, for example, it's probably not the best idea. We want reproducible results, and it's also nice to have full control of the deployment. So what happens today is that ovn-heater test runs are happening on bare metal in Red Hat Lab downstream. Nevertheless, it turned out to be a very prolific exercise. We found quite a few bottlenecks in OVN components, OVN controller and NorthD, but also a lot of improvements were possible in OVSDB server, thanks to ovn-heater finding the bottlenecks. And yeah, Ilya had a presentation about that last year. However, the best way to scale test the way OVN is used by a CMS is to actually deploy that CMS at scale and run tests against it. So in Red Hat, together with the dedicated perf and scale teams, we test OpenShift at scale. We bring up large clusters, 120, 250, 500, sometimes 1,000 nodes, and then we run real workloads on these clusters. For example, KubeBurner is used to generate those workloads. And then we collect relevant OVN information, logs, databases, and so on, and other metrics that are relevant for the tested workloads. What's the advantage of that? Well, the advantage is it's a real OpenShift deployment, so there's no gap between simulation and what the CMS would configure. The disadvantages are, of course, it's harder to integrate upstream. like I mentioned earlier, it requires more CMS-specific knowledge whenever we debug issues. It's more complex to set up than ovn-heater, for example. So that's why we usually triggered it on demand. Just a note, there are ways of deploying OpenShifts on bare metal in VMs with custom OVN-Kube images. So it is possible to create a CI pipeline that would test real OpenShift with vanilla upstream OVN code, and that's actually something that's work in progress for us. Another type of testing we do for OVN is data plane performance testing. We do that for in order to detect regressions in the data plane throughput and latency, or connections per second rate. What we do is run tests periodically with OVN-only clusters. We combine various traffic patterns, trying to replicate common Kubernetes and OpenStack scenarios. And we're really focused on the data plane performance. We don't run any control plane scale tests. We also use a hardware traffic generator outside of the system under test, and that's to remove the noise of traffic generation from the results. So now that we went through the list of all different types of CI that happens for OVN, let's have an overview. So if we take, for example, a patch that was posted to the mailing list, as soon as that happens, it will show up on patchwork. And at that point, OVS Robot will notice that and apply the patch to the corresponding branch, run check patch, push the series to its own fork, and then reply with the results to the OVS build mailing list. As soon as the commit was pushed to OVS Robot's fork, GitHub actions are triggered. Those generate results. OVS Robot fetches the results of the GitHub actions, parses them, and then sends another email to the build mailing list with a link to the unit and system test results, and also to the OVN-Kube test results. So all this is mostly automated. Then, if the patch is accepted, maintainer will apply the patch to the OVN tree. And then on GitHub, that triggers GitHub actions, but also Cirrus CI actions. We run tests on ARM on Cirrus CI, and those generate GitHub actions results and Cirrus CI results. And every now and then, we unfortunately missed some failures, but recently, thanks to Ilya, we now have build badges on our GitHub page, so we can see whenever some of these tests are actually failing and address the failures. So aside from the patch-triggered CI events, we also have scheduled events. Weekly on GitHub, we run system tests with OVN Multinode. We also run unit and system tests with the most recent OVS stable branch. Normally, we link against what's defined in the OVS submodule, but we want to ensure that most recent code still works too. Also weekly, we trigger a build of a custom OVN-Kube container image with the latest OVN main code, just to make sure it's still built. And then downstream, we run OVN-heater in our Red Hat lab, like I mentioned, and we execute tests that simulate 20, 120, 250, 500 nodes with IPv4 and IPv6 and various simulated workloads. Also weekly, we run the data plane tests I was talking about earlier, also in our lab. The problem with the last two items here is that there's no automated mechanism to report the results upstream. That happens normally through emails or bug reports or even patches directly, but there's no automated way to do that or formal way to do that. Okay, so we have all this CI. How can we improve it? From a stability perspective, there's quite a bit of things we can do. We can try to improve the entry CI. We should detect unstable unit and system tests. And recently, we accepted a patch that disabled recheck in CI. That means that whenever we have flaky tests, we should be able to detect them faster than before. The second item is about fixing those flaky tests. And that's an ongoing effort. In the last 12 months, there were more than 100 commits that fixed tests. That's great. But we still have a few that need addressing. Another important thing that came up recently is that we must make sure that the version of non-OVN components that we use in our testing, for example, Python version or OS versions or whatever, are more or less fixed to avoid introducing noise in the CI. And part of that is addressed already. Part of it still needs to be addressed. There's a series posted by Alesh on the mailing list up for review. Another thing we should improve is how the tests actually look. Some of them are too complex or slow. And one way of improving that, for example, would be to use format packets more often. Now that it's becoming quite fast. And one pain point for OVN-CI was testing with OVN-Kube, end-to-end tests. We should probably start using stable OVN-Kube releases once they appear, instead of using the latest OVN-Kube code. Okay, and from a coverage perspective now, how do we improve on this? We need to probably expand the control plane scale testing by adding support for different types of workloads, for OVN-IC, for example. Part of that is already done, part of it is in progress. We should start running those tests downstream, and we should also add more OpenStack scenarios. A very important way to find a way, in Red Hat probably, to automate the way we report results from downstream to upstream. The same is true for the data plane testing infrastructure. We should test more traffic patterns, and we should automate the way we report the results. And finally, I mentioned earlier, there's work in progress to get a CI pipeline to deploy OpenShift with vanilla upstream OVN. Once that happens, that should also catch issues if they appear. And so we need to complete that work, and we need to automate the way we report the results. That's it for today from me. If you have questions or suggestions or feedback, feel free to ask. Thanks, everyone.
All right. Thank you, Dimitri. I think it was a good talk. I can make a good overview of what kind of tests are run. I guess also maybe a question from you to everybody is that if you're using something else than Kubernetes or OpenStack, I guess that's what we're internally focused on. That if there are specific other CMS use cases, they should probably reach out as well, right? To get the those kind of tests integrated if really needed.
Yeah, you're right. That would be nice. And I know there are a few others.
Okay.
And yeah, we try to be nice to the users of OVN, and that's yeah. If we know what to test to make sure we don't break their use cases, that's something we can do. We can run those tests.
Yeah, cool. Yeah, I think you guys need input from other upstream folks, right? So that's good.
Right.
I see we have some questions, so let's go through them. I think the first question is from Aaron, and his question is it possible to use a dummy patch to upstream that could be used to send a weekly report against? So
I guess so, yeah. That's probably one way to do it. It might work. Maintainers usually use patchwork to monitor the state of incoming changes. Maybe there are other ways, but this is an option. We can look into it, yeah.
Okay, cool. And the other question is, can we have check patch to be run as part of the OVN repo. I know we do it for the OVS one, but it seems like it's not been running for OVN. Are you guys aware of that? Or?
I think checkpatch runs. I think it's one of the actions the OVS zero-day bot does when it applies the patch. I think it also runs checkpatch, but I can.
All right. So the question for if it's been run part of GitHub action. Okay.
We could, yes.
Yeah. All right, that's cool. I guess people could always submit a merge request for that one, right? So maybe
we accept that.
Yeah, I can get that to work out. Cool. All right, I have another comment from Aaron. The OVS robot infrastructure can be supported in any labs to send a test report as long as there is a patch to report again. So maybe we can encourage these labs to push results to the patches themselves. Does that make sense?
It makes sense. One reason why we don't do that is that we, like I said in the presentation, we run on bare metal. Some of our testing. We try to avoid running any running tests with any patch that was posted that potentially didn't see any review from a human maintainer. That's why we run with accepted versions of the code. But yeah, we can improve our tools to make it safe to run on any patch, I guess. And then we could report results for every entry on patchwork, like other labs do today.
Okay, cool. Let's see if there's any other questions. I don't see any questions in the questions. Let me just check the messages. All right, that's about the GitHub actions. Yeah, yeah. I recently got that example. So yeah. All right. So thanks everybody, and thanks Dimitri for the talk. I see people already clapping, so that's good.